covered, but. And I guess really that's what I ought to. So I think what I ought to, maybe you'd have to correct me if you think I'm wrong. I'll go through the sections. Unit 5 is unit 4 is the first one, surfacing, and I'll go through what I think you should know. And if you all go, no, we can't do that, then I'll do it. If you all say no, that's okay. Do you see what I mean? Otherwise, I don't know where to start, really. I don't know where to. The first workshop 5, that would have been in September, is surfacing, vertex distance and effectivity, tints and coatings, and lens material comparisons. That's what I would have done. So lens materials, surfacing, tints, and vertex distance. Those are the 4 bullet points. Now, all of those 4 would have come up pretty much in the exam. The surfacing is in unit 4. The vertex distance is in unit 5. That's ophthalmic lenses. Tints and coatings would have been in unit 10, I think. So what should I do? Should I put some stuff on surfacing that I think you should know? Yeah?
Yeah.
I'll put it on the board and then...
Ophthalmic lenses is the ones that we've struggled with.
Yeah, all right. Okay. So
the whole year has been pretty challenging.
Yeah.
I'm sure it has. We feel like we've trained ourselves.
Yeah.
Yeah.
Using books and the internet.
Workshops in there and stuff.
Mm-hmm.
I know.
Yeah.
Not good. Well, if you're saying, I mean, surfacing, basically, you need to be able to do, if we get rid of workshop 5, unit 4. Unit 4 is the surfacing one. You need to do, can you see this? Yeah. Mm-hmm. Digital. So you need to be able to talk about those 2 methods of surfacing, free form and conventional with laps. With this one, there's not a lot of sums, because digital surfacing all boils down to the SAG formula, yeah? So it's Z is R minus the root of R squared minus X squared, doesn't matter, minus Y squared. With the X and Y coordinates, it's the SAG formula, Does that make sense? I mean, if it doesn't make sense or you don't know what I mean, just say. But it's finding these Z numbers at any given point on the lens. There's your lens. What's the Z number there? What's the Z number there? And this is the X axis and this is the Y axis. They give you the coordinates. They say, what is the Z number at a point 10 millimeters up and 5 millimeters in?
Mm-hmm.
See what I mean? And you either be told R or given the lens power, and you can find R. Says he, not being able to remember what to do.
N-1, is it?
Thank you. No, I can't remember. It's been a while since I've done any, but yeah, you can find R of the whatever surface. It won't be a complicated surface, just be a surface. And so you find the Z number. Do you get the idea? Yeah? And you work if it's at this point here, you'd work out what the Z value is for that. And of course, you could do the same here, which is what the computer does. It does all those SAGs a bit quicker than you do. So that's all you need to know, really. But they know what digital surfacing, know that it's this a generator that works out these Z numbers. The computer works out the Z numbers, the generator follows it. And the polishing is a very straightforward process where you don't need laps. It's just a pad, yeah? The actual technique of describing one of my silly stories. As you might be able to see, I went for a haircut yesterday, and I said the hairdresser, young lad, and he said, "Oh, what do you do then?" I said, "Oh, I like lots of things. I do all sorts of things." He said, "Well," he said something about. I said, "I'm actually this week I'm teaching optical technicians how to make lenses." "Oh, that's interesting. How do you do that?" I said, well, it's a bit complicated. Thanks, Joe. How do you make lenses? So in the space of having my hair cut, I did digital surfacing, conventional surfacing, and glazing. How about that? His head, he looked a bit puzzled at the end. No, he didn't actually. He said, oh, that's really interesting, isn't it? So I didn't give him the SAG formula. I didn't think that was appropriate. So anyway, digital surfacing, it's finding a Z number for a given point, and R is that, and then talk about it, yeah? That you can polish any, I'm sure you don't need me to. It's so much more straightforward than conventional. Conventional surfacing, you've got to talk about laps, and there's this tool power thing. With this, the computers the index of the materials put into the computer program. With this one, if your laps index of these don't match the index of the lens, you have to do this calculation, and it is likely that you would be given one of those to do. So this. Remember me doing this? Well, perhaps you don't. Perhaps I haven't done it with you. I don't know. We usually call it tool rather than lap. Because one of the questions that one of you sent in, I don't think I made a note of who it was sent in what, but somebody wanted to know about this. Does this ring any bells with you? So you have this is all equal to the radius of curvature, but you don't need the radius of curvature. So the index of the tool, the lap, whatever the tool is calibrated for, divided by the power stamped on it, is equal to the index of the actual material being used. So this might well be 1.498. This might be 1.7. You see what I mean? And that's the actual surface power required, and then you cross multiply to get it. So invariably you're finding F tool, you're finding that, that one, what material you're using, the surface power you want, the index of the laps that you've got. It's that one that you don't know. Does that make any sense? I'll do one if you want me to, but I mean, basically, if you want to know what this is, you'd multiply the actual surface power by the n minus 1. Remember, it's n minus 1, so this might be 0.498, 0.498, yeah, for CR39 and tools, and this would be 0.74 or whatever the index is. Yeah, so to be that one times that one divided by that one. Not that difficult. Just a word of warning, though. It might say, for example, -6 lens. That's the power on a on a 4-base semi-finished blank. So that's what this is a conventional. Remember, we've done with that semi-finished blank. Now, a common error when I used to mark these things was people ignored this and just used the 6. Obviously the 6 is important, but it's not the surface powers. So this lens, 4 base, means the front surface, which is already finished, is +4, of course. So F1 is +4. And F2, you can all work out, can't you? It's got to be -10. And it is that will be you will be surfacing the 4, but students, because in its exam and things, they would go ahead and use the 6 because it's meaningless to use the 6. It's surface power that you want, and we don't need the front one. You won't be asked about the front because I hope not anyway. Invariably, the front surface is finished. We don't do it in this country much. We buy them in for reasons I'm not entirely sure about, but we buy them in semi-finished. So, I mean, there's other bits of surfacing, provided you can talk about digital surfacing and that it's a computer CNC generated surface, And you can talk about the polishing, which is just a flat pad which will polish any surface. You know, it will polish my watch face if you put it on it. It will polish anything. Whereas the conventional, you've got to have laps, which are either the same index as the material you're using, or they're not. That's what you'll be asked, where the lap is not the same. This index is not the same as this one. And you have to find the tool required. The polishing, of course, for this, you have to have another set of laps. You could use the same set, put a pad. Now, I can go over that now, but I would look it up if I were you. I could go over pad compensation, but for suffice to say, even if you could explain it, you could have your lap. There's your lap. Sorry, I'm out of camera. There's the lap. You could use the same one for polishing, but you have to put a pad on it. And when you put a pad on it, it changes the radius of curvature. Mm-hmm. And so you need to allow for that when making a set. You don't have to have a separate set of laps. You can have the same set and put a pad, but most manufacturers actually use the same thickness of pad for surfacing as they did for polishing. And so there was only really one calculation needed to be done. But I think even if you couldn't work out the polishing thing, as long as you could explain it, that because the pad used for surfacing has a certain thickness, it changes the radius of curvature, and this must be allowed for when polishing the surface. So obviously it's a lot more complicated, it's a lot more expensive. Well, no, perhaps not. Once you've got the gear, it's not expensive anymore, is it? Once you've got all those laps, hundreds of them. Whereas I'm sure the computer that generates the digital generator, I'm sure that's all terribly expensive, but well worth. I mean, it just being not boring for a minute, but just I hope you understand how amazing this digital thing is. Really, that you ought to make sure you mention. I mean, in the old days, for the last 200 years, you had to have one of them so that your lens came out like that. You know, you had to have that to match this. Now you don't need that anymore. You just have a thing that. And what I can't understand is, why did nobody think of it before? You know, because what you have with the digital, you have a flat surface. Say that's where z is equal to 0, and then you put these other numbers in, and of course it plots. You have z, you know, all these different z's. Do you see what I mean? I don't know why we never never was thought of that you could, if you knew that sag and you knew that sag and you knew that sag. Anyway, we didn't do it, but we do now. So is that enough on surfacing, do you think? Do you see what I'm getting at? If you're happy with, if you want me to do one of these, I'll do it.
It would probably be beneficial, yeah, I reckon.
Do one.
I think, yes.
Just a quick,
Yeah.
I'll do this one that I've done here then. So let's say it was a semi-finished. No, I don't want to belittle it. You know what I'm saying? I just don't want to bore you with it. That's the lens power. And it would say it's a +4 semi-finished blank, +4 base. And remember, when the word base is used with semi-finished blanks, it means the sphere curve. There is this perennial confusion between base when applied to a blank and base curve when applied to a toric transposition. Can I just remind you of that? When it says base curve, do a toric transposition with a such and such base curve, it's this one. It's the base, then the cross curve, and then the sphere curve. Yeah, first year toric transposition, which I hope you can do, though a lot of people have difficulty with it. But when we're talking with semi-finished blanks, the base that's given is the sphere curve. It's unfortunate, but it's just the way it's grown up, and it's just the way it is. I mean, if you've got a great big lump of plastic that's only got one surface finished on it, and in this case it's +4, what do you call it? You see, I mean, ideally we should have just said, oh, it's a +4 sphere curve blank, but nobody wanted to say that, so they just call it a 4 base. Does that make sense? So hopefully it would be made clear in a question, but if you're given the base of a blank, it's the sphere curve. So it could be that you might be given this as a toric anyway, but even if it were a toric, if it was -6, -2 axis, doesn't matter what the axis is, -6, -2, you'd have to do +4, which is given. Yeah, and then you'd have -10 here, which gives you the -6, and -12 there, which gives you the 2 sill. Does that make sense?
Mm.
So if it's a sphere, it would just be +10, +4 and -10 to make our -6. But if it had a 2 sill, then you'd have the base still, and then 10 for the base curve and 12 for the cross curve. And it just means you have to do this twice, which is no big deal. If you can do it for one, you can do it for the other. Do you see what I mean? Yeah, you'd have to do it for the 10, which lamp for the 10, which lamp for the 12. I'll just do the 10. But you know, all I'm saying, taking time to tell you about it, is that I've seen exam papers where people get it a bit, they do the formula right, but they get the powers wrong. So we're just going to do that, +4 -10. But if it was a 2 sill, it would be a brief toric transposition too. All right. So I'll get rid of all this stuff. You all look pretty fit anyway. I take it we've all, none of us, have you succumbed to the dreaded lurgy? No? I have.
Oh,
I had it. Yeah.
Okay.
And worse, I went at Christmas, just very quickly, just makes a change. I went to South Africa for Christmas because you were allowed to then. You were allowed to go. And I went with some friends to South Africa and I got the South African lurgy, but no symptoms. Didn't even know I had it. Didn't know I had it.
You brought the variant back.
It was me. It was me. I was the one. I had a doctor come up from Oxford yesterday, day before, to take a load of blood from me because there's only a few people they've got that had it, you know, that have had the South African one, and they're doing tests on it now. Yeah, but I didn't know. Honestly, I had a test because I had to have one. They said, "Oh, you tested positive." What? No symptoms at all.
Jesus.
I was my normal jolly self. Can you believe?
I've been doubled, so hopefully
You've been?
I won't get it. I've had both my jabs, so I shouldn't get it. Hopefully.
Me too. Well, yeah, yes. What, the Pfizer one?
Yeah.
Yeah.
Unfortunately, they're now discovering that. But you know, don't go to South Africa and don't go to Southeast London because it's been. There is some evidence it can jump the Pfizer jab, the South African one. Yeah. But
Great. Fabulous.
Don't let me. Why are you crying? We went to this lesson today on surfacing and he told me about my jab not being, and this doctor was saying, you know, the jab is the jab and it's jolly good, fantastic. He said, but it is not the be all and end all. You know, you still got to be very careful.
Yeah.
Cheers. Neat chin. Right. So we've got.
Can you hear me now? Yes, you can.
Yes.
Again?
We can hear you.
I'm on my phone now.
Oh, hi.
Hi.
Nice to see you and hear you as well. Brilliant. So we've now got three of us. And
I don't know why on my laptop.
We've got Callum, haven't we? Yes. Callum's there. Agatha's there, yeah.
I'm here.
Somebody's Alec. What about Alec? No Alec and no Abby? I'm here, but no camera. Yes, Abby's here. Yeah, all right. Well, yeah. Oh, no, I'm here, no mic. Okay, Alec. Yeah, I think you did say. Okay. Well, bit of a problem that. If you want to ask a question, you just have to type it in. I can see it. So if there's anything. So this is this tool power thing. Then it's a semi-finished +4 blank. We want to make -6. The tool rate, the lap, same thing. Range, let's say, is CR39. You should always be told the index, but I'm sure you know the index is 1.498. And let's say the lens material is 1.66. Is it 66 or 67, the common material? 67?
67.
167.
One.
Yeah, 1.67, yeah. Let's say it's that. So the equation you use is this one I said earlier, n minus 1 of the tool over f of the tool is n minus 1 of the actual material. That's what actual means, over f actual. And you with this equation, well, it's not an equation, it is an equation, isn't it? They're both equal to r. You just need to go through it to say, which ones do I know? Do I know the index of the tool? Yes, we know that one. It's 1.498. Don't forget to take the 1 off. It's n minus 1. So we know that. Do we know the actual index used? Yes, 1.67. So it's 1.67 minus 1. Do we know the actual power? Remember, it's the surface power. So in this case, it's minus 10. Yes, we know it. Agreed? But you'd have had to do a bit of, it's a +4 sphere blank, so therefore I want minus 6, and therefore it's minus 10. Or like I said, a toric transposition where you have the 10 and the 12. And we don't know that one. Invariably, we won't know that one. I think it's pretty much certain that's the one you won't know. So you cross multiply. You'd say F tool, the one that you want, is n minus 1 tool, that one, multiplied by that one. Worth remembering that. Oh, sorry, I'll move this along. Worth remembering cross multiplication. It's a bit of a cheat, but it works. Where am I? N minus 1 tool, F actual, divided by n minus 1 actual, divided by that one. So you multiply those two, the diagonals, you multiply those two together and divide by the one that's left. Look, it's a useful trick. So once again, this one, the one we want, is that times that divided by that. It's always going to be that, really. So it's 0.498, isn't it? Common mistake is to leave the 1 out because you just forget. Multiplied by minus 10 divided by 0.67. And that, incidentally, that little bit there, it'll come up in unit 6, lens materials, and we'll come to it later, but lens materials, comparisons, that's the curve variation factor. Do you remember using that? When you get a number, perhaps I don't want to confuse it, but that's what it is. 0.498 divided by 0.67 is the curve variation factor for that material. Anyway, now the only thing you have to do this for me because I have got a calculator, but I don't know what I've done with it. Can you do it? So 4.98 divided by that.
Minus 7.43.
3. Yeah.
43.
Yeah.
Brilliant. So that sounds good to me. So that is the lap you require. Now, of course, you won't have 7.43 laps. And usually the question says, assuming that you've got an 0.12 tool range, which was pretty much common in the industry, you've got a set of laps that are in 0.12 steps. You've got to find the nearest one to that. Well, it'd be 750, wouldn't it?
Yeah.
Because this would be, 725, 737 or 38. and then 750. So it'd be a minus 750. So that's really it. They're not that difficult. And if there was a cross curve, the minus 10 or whatever it was, minus 12, you'd do the same again, but with the new numbers. And that, I mean, I could go through over every bit, but the polishing pad, I wouldn't worry too much about. It might ask you, what is the radius of curvature of the polishing? I would just explain about the polishing pad, that it has to, the radius of the thickness of the pad has to be compensated for. The majority, if there were 20 marks on this question, 15 would be for this, and 5 would be for the polishing pad nonsense. So we just have to cut the cloth at the moment according to the weave, don't you think? Keep to the stuff that generates the mark, and be able to list. That's the other important thing. The digital surfacing, the various stages, semi-finished blank, put it onto a button, and then digitally surfaced, and then polished with a flat pad, and that's a digital one, and some more waffle. And the conventional one is where you have a set of laps for smoothing, and another set of laps, more or less the same curvature for polishing, more involved process using emery and various unctions. Use a metallic oxide to do the polishing. You can read that up. So, at a stroke, we've got rid of that, I hope. But I mean, I don't want to be going too quickly. I don't want you to think, he's glossed over that. But I think that's enough. If you can do that, and you can do the Z value thing, which we said just now, for the digital, R squared minus X squared minus Y squared. Not difficult to do. You'll only be asked to do one, just so as you've done the Z value. Z, of course, is sag, isn't it? It's just we decided to call it X, Y, and Z. Okay. The other one that comes up in surfacing a lot, which I'm not going to do, but you can look it up, is the inputs and outputs of surfacing. What you have to buy in if you're a surfacing lab, what you have to buy in, blanks, for example. You have to have machinery, you have to have the emeries and the various things. So the inputs, what you need, and then what the outputs are, which of course are finished lenses, finished uncuts. Yeah. So it's in your notes. Read those. That comes up a lot for reasons I'm not entirely sure about, but I suppose why not? Why shouldn't it come up a lot? So worth looking that one up. Well, something's going wrong here. Miss specs are not. Oh, there. That's better.
Maybe we should start doing our assignment.
Doing the assignments? Which one?
Yeah, we have a revision now.
Yeah, we're in revision.
I'm going to take this off a minute. Hang on.
The free revision assignments.
Well,
That would make sense, actually, no?
yeah. You've got revision for what? For the exam?
No, that's our assignment, yeah.
That's the assignment you've got now.
Yeah, the first one. First revision. I have to print it.
See, I haven't got that. I haven't got that with me, but you can ask me, and therefore I haven't necessarily prepared for it, but you can fire away. I mean, yeah, this is the revision for the summer exam. Is that right?
Yeah.
Yeah. All right. Or if you're taking it in the winter, it will be in the winter.
I don't know what to do, to be fair, because I can't travel.
Oh, can you not? They're not allowing you. They're not allowing you out.
No. So I don't know what to do.
Have you explained that to Abdo?
No, I haven't. It's actually really hard to get to them. Like, I tried to ring a few times once, and like there's always a voicemail. I left a few voicemails. No one never get back to me. But
Well,
yeah, anyway,
I will mention it at lunchtime.
Yeah.
I'll mention it at lunchtime, see what they have to say. But traditionally, the theory exams, where are you? I've forgotten where you are.
Dublin.
Yeah. Traditionally, they did hold the exams in different venues. You know, I think they did it in Scotland and in Wales, but I don't know that they did in Ireland. But theory papers are not a problem. It's the practical that's the problem. The theory probably could be held, for example, at the British Embassy or something like that. I mean, I'm only guessing, but we have done that before, where you would go along to one of the embassies and the papers could be taken there. Do you see what I mean? But I'll ask at lunchtime. I'll ask.
What's the practical exam? Like, what do you do on the practical?
Well, you do practical things. I was going to, if you don't all give up after, it's up to you. But I was going to run through the practical tomorrow, just a chat tomorrow afternoon, for example, just to go through what you're expected to do. Yeah, I think we should get the theory out the way first. But I certainly will go through it, so you know what you've got to know. And if you don't know whatever in this section you have to do blah blah blah. If you don't know blah blah blah, you've got time to go and find out. Yeah, I can certainly go through it with you. Yeah, not that hard, the practical really, but depending on but it a bit daunting perhaps. Right. So what about this? What about this thing then? This revision thing, which is what you're having to do now.
You want us to read out the first question?
Say again.
You want us to read out the first question for you?
Yeah. I see. I haven't got it. Yeah. Go on then.
So 1A is a fused bifocal is made as follows. Rx is -3 + 1 at 90. An addition of +2 in toric form of a -6 base curve.
Go back. I got that bit. What was the next bit you gave me? Oh, a base curve?
So it's -3 + 1 axis 90.
Yeah.
Addition of +2.
Add a +2. Yeah. Sorry. Yeah.
In toric form with a -6 base curve.
All right.
Main lens is 1.5. So the refractive index is 1.5 of the main lens.
5.
And the sag is it's 1.6, the seg lens.
Right. And it says find the radius of curvature of the depression curve. Find the radius of curve.
The power of the depression curve.
The power.
Yeah, calculate the power of the depression curve.
All right. Well, okay. All right. Yeah, sure. I'll do that one. I mean, it's what I was going to do was, if you give me a question on that revision thing, if I don't know who writes those revision things, but some of them, what I've looked at in the past, the exam questions have never come up on that subject. You know what I mean? So they're getting to revise something that's a waste of time. However, this one, fused bifocal, does come up pretty much, not every time, but pretty much every other time.
That one or which one?
Fused bifocal.
Right. Okay.
Yeah. So it's worth. All I'm saying is it is worth doing, because it does come up, and we would have covered it in one of the workshops. You see. You know what the fused bifocal? It's one of these. One of the guys that works at Norville said to me before, "Why are you still doing that? Why are you doing that theory?" It's not my fault. I mean, I'm not. But because we don't, I mean, they're still available, but nobody makes them anymore. They're glass. Yeah, nobody does them. There are plastic ones, but they're contact lenses. Contact lens bifocals are fused in a sort of a way. They're like this. This is the distance bit. This is the segment, and that there is FC. That one, and obviously, that's the contact surface called FC. And depending on how steep that is, will affect the ad. The two things affect the ad: how steep that is, and how steep this one is, which is F1, front surface power. If that's very steep and this is very steep, you've got a big ad. You get the idea? So that's all there is to it. And of course, the other thing that makes the ad, one is that curve, and the other one is the index of this, which is called NS, which you've told me is 1.6. And this index, which is main lens, which is 1.5. And not because there's a difference between that and that. That's where you. So the add is due to that change in index, that and that, and these two curves. Well, you know that one from your toric transposition, but you don't know FC. So that's why they get you to find it. Yeah. And if you were making, if you decided to go, I think I'll go and make a fused bifocal, you might say, I fancy making one in my shed, then you'd need to know FC. Does that make sense? So the important formula then is for FC. And without this formula, you can't do fused bifocal problems. It is pivotal. So you need to remember this one. So it is FC. I won't put that line. It looks like a toric transposition. It's that. The power of the contact surface is... What's that noise? Can you hear a funny noise?
Yeah.
Maybe that's my laptop. Hold on.
It sounded like a car. I thought it was a car coming into the room.
Because I have my phone on the laptop.
It's all right, darling. I understand.
Sorry.
What's the weather like where you are? They're absolutely glorious here. It's freezing cold, but it's beautiful. And this place where I'm working from, I don't think I daren't move this camera because you probably won't. But it's we're in the middle of the Sussex Kent countryside. It's just down in Kent, near Canterbury, and it's just. I think there's 90 acres of land, and you just can't see anything apart from green grass, trees, and lots of sheeps going and stuff. It's just really lovely. I mean, I would actually rather look out the window at the view than I would looking at you guys, but it's a very unkind thing to say, but no, I'm only joking. You look much nice. You know I'm joking. You're keen. Right. That formula is the most, you have to know it, because if you don't know it, I quite often say, well, you could do this from first principles or something, you could work it out. You can't. You need to, where I could show you where this comes from, but you don't want to know. That's the formula. That's the contact surface you want. That's the front surface power of the lens, which you'll get from a toric transposition in a minute. Mm-hmm. A is the add, fair enough. But K, this one, you don't know. It's another formula. It's given by this. It's a ratio between the index of the main lens and the index of the seg. So that K is given by that. N minus, what can you see it? Just about down the N minus 1 divided by NS, the segment index, minus the main lens index. We'll do that in a minute. So to find, we need to find F1. Agreed? Front surface power?
Yep.
And you'll have to do a toric transposition. Unfortunately, they've put the prescription in the wrong form for this base curve. You may remember first year toric transposition, when the base curve's given, the base curve in this case is negative, you have to have the cylinder the same sign. That sign and this sign must be the same. Do you remember? Toric transposition.
Yeah.
So you have to do ordinary transposition first, absolutely right. So the RX, we'll put a bracket around that. The RX we'll use is -2, -1, axis 180. Mm-hmm. Yeah. Now they often do it like that to wrong foot you, unfortunately. It's an examiner's trick. So that's going to be the RX we're using. And in toric form then, I'll do it over here. It would be, doesn't matter which side you put these on. There's the -6 base curve. And you've got to fill in that one and then that one, which is F1. That's what we want. So the -6, do you remember? You just add the -1 axis 180 to it. So you've got -7 axis 180. Yep. Mm-hmm. And then this one should be, you have to put axis 90. Don't forget. That gives you your -1 axis 180. But you must put this axis in. We're not going to use it, but you have to put it in. Mm-hmm. Right? And then the sphere curve, what do you think it is? -6 base +4. Absolutely right. Yeah. And it's worth checking. That is F1, ds, if you like. Worth checking, just add them up, and it comes to -2. You know, if you add those two together, it comes to the -2 sphere. Because if you make a mistake, I mean, if you did make a mistake and you've got the wrong number here, you still get marks for putting it in the formula, but obviously you really need the correct answer. So that's what you have to do that toric transposition for. So you can see, can't you, lots of places to go wrong. You might not transpose, which you should have done, in which case you'd be using the wrong curves. So transpose first to that one. Then toric transposition, -6, -7. That's adding the -1 at 180 and getting the front surface of the sphere curve. So we've now got that one. We've got the add, it's +2. We just don't know K. K, which is this ratio, is n-1 divided by ns. That's the segment index minus n. So it's 0.5 on the top line divided by 0.1, isn't it? This is 1.6 minus 1.5. Yep.
So I've
Which
gone
you can
on
see.
for that.
What?
5 is the answer, is it?
It is.
Yeah.
5.
So what?
It's normally it's normally that sort of number, 4 or 5, but it can be other numbers, but it's usually around that sort of number. If it came to 399, for example, you'd call it 4.
With 5, is that what sort of?
It's just 5. It's a
just
relationship between one and the other. It's just a number. Yeah.
So it's not
It's not diopters or +5 or no. It's just a number 5. So we can get rid of this question, can't we now? So you can just put the numbers in the formula. And it shouldn't be too difficult from here. FC is F1, which we've decided is 4, minus, you have to multiply these together, of course, the add, which is 2, times 5. And that comes to 10, so it's -6 is the contact surface power.
What is it?
-6. Pretty, I mean, if you know, it's like all these things. If you know the formula and you know how to work that out, it's relatively straightforward. That's what it means. Then the lens would look like this. You don't need to know this, but that would be the thing. This would be the contact surface. So this is +4. This will be -6. And that's the back surface I'm not bothered with. And then this will be filled up with that high index stuff. Very clever, really, fused bifocal. It's American invention, you know. They said, you know, we don't want this line between the distance, and we don't want this changing curve, which you can feel. But I mean, a bad example of where there's a changing curve be the executive, where you've got a big step. But even other bifocals have got a step. In plastic bifocals you use now, aren't they? They got a step, you can feel it. And they said, hey, we don't want that. We want something, you know, sorry about my appalling American accent. And she comes from Dublin. I was only invited once to Ireland to do a lecture to one of the Irish Association of Opticians. They said, would you come and give us a talk about things? And I did. And I don't think they thought it was that good, but I thought it was good. And I gave them all the stuff. And then I don't know what possessed me, but I told this joke, which involved somebody that was Irish. So I put on the Irish accent and told this joke, which went down like a lead balloon. And one of my students was there, and he came and said, I don't think I'd do the Irish accent if I were you in Kilkenny, which is where I said, no, you're probably right. Completely stupid. Anyway, yes, there we are. Oh, now, oh God, I keep getting this deafening. You might be asked to find the radius of curvature of the depression curve. They often ask for the radius of it. Power first, you have to do that first. But radius of curvature, you know the formula for radius of curvature, but do bear in mind you're using the index 1.5, not 1.6, because the contact surface is on the main lens, on the crown lens, not on it is on the segment, but we don't use that. So to find the radius of curvature, RC, if you like, will be n minus 1, 1.5 minus 1 times 1,000 divided by FC, which is minus 6. Do you see what I mean?
Yeah.
I mean, you can do it, but that's what you have to do. I can tell you it's 500 divided by 6, it's 1,000 divided by 12. It's minus 83.33 millimeters, if you want to do it, right? So they quite often ask for that radius of curvature. That's about it. The contact surface is almost always negative. It can be positive, but it's almost always negative. So you'll end up with like minus 4, minus 6, minus 8, whatever. Yeah, fused bifocal. I don't think you need to know anything else much more about them. That's all there is, really. Ask me another. Is that okay?
Yeah.
See, worth doing because it does come up. It does come up, not every time, but fairly frequently. Even though, as this guy was at Norville was saying, why are you still doing it? We do about one fused bifocal a month. Not my
There's
fault.
a
Not my problem.
second part to this question as well,
Go on. Oh, right. Go on.
which is if an add of +3 were required with all the parameters being the same, what would the refractive index of the segment need to be?
Right. Yeah, they changed the index of the seg. They used to change the curvature of FC, but towards the end of their product, well, not the end. Now they think they do it now. They call it compatible flint. They choose a different index to give you a different add. Can you imagine if the seg is like that? If you use 1.6 index, you get whatever add. If you use 1.7 index, you get a more add. You can change it. So they're asking what index would that have to be in order to give you an add of 3? Is that right? Was it?
Yeah.
Yeah. Add +3, NS equals, we don't know. Well, going back to this equation, all the other parameters are the same. So we now know that one, don't we? We know this is -6, was it? Yeah.
Yeah.
Agreed? We know F1, because that's +4, that hasn't changed. We know the add, you've been told, to make it +3. So it must be the K ratio that has changed. Hello.
Hello.
How are you? How are you?
I'm a bit stressed. I can't get this to work.
Well, it's working now.
I've had to put it on the iPad because my laptop keeps crashing.
Ah, well, you're here, looking as handsome as ever, of course.
For some unknown reason, I can't get you like full screen, so you're just like a small square.
It's probably just as well. Sometimes it's God's way.
I know, but it's quite hard to see what you're writing.
I know.
Oh, I
I
see.
don't see much as well.
Oh,
If you go
Like,
to the
on it-
top,
If you've got a laptop, you could just select who's talking, but on the iPad, it's not allowing me just
You're
to
just
select.
No, I
tiny-
can't.
No, I don't know why. It's
can I call one
I
of the
can do it
guys?
on my phone as well.
oh, wait a minute, I've got it.
What did you do?
I just clicked on the camera section and it's got a view webcams all talking or none. I've selected talking. Now
You
it's
hear
just
that, Agatha?
Yeah. No,
Can you
I
hear what
can
he
see
said?
it, but it's only like a small square, but that's just
Yeah,
because I'm on my phone.
What did you? Can you tell her what you had to do?
Oh. No, she has got it. It's only because she's watching it on her phone. So
Oh, I
what-
see. Oh dear.
It's fine if you. No, I can see it actually, but like sometimes
It's not
you have like
easy.
small letters, like for
I know.
formulas or something.
You want to
If
use?
I will have
you
to
wanna use
read it for
these?
me.
I've got
Yeah, I have glasses actually.
I've got a
somewhere.
250 ad on these. Might be handy.
Will do.
So what are we going over? Is this revision 1, Alan? We're going over.
We're going through the revision sheet that you've just been given, the assignment. Well, only
right,
because
I
it's
see,
been
yeah.
suggested that I do that.
Okay.
Yeah. But I mean, we've done a bit on surfacing.
Right.
Just basically what comes up in the exam.
Yeah.
Back to this one then. We know FC because we worked it out just now. We know F1 because it hasn't changed, it's +4. We know the add, we've been told to make it +3. The thing that is going to have to change is K. K was 5 just now. It's going to have to be something else, right? That makes sense? So, we need to rearrange this equation, don't we? We need to rearrange this, which I know you guys don't like doing. We need to rearrange it for K. It would be easiest to rearrange it for AK first. We're going to make that a subject, AK, yeah?
Mhm.
And then we can isolate K after that, because that's what we need to find. Once we know K, then we can rearrange K to find, you'll see what I mean, it's not that hard to find NS. So first thing to do is AK. Well, yeah, it depends which way you want to do this, really. I mean, a simple way is to say minus AK is FC minus F1. You see what I mean? That whole thing there, minus AK is that, take away that. I don't know how good you are. What I would have done when I was a boy, which I was once, I would put in a numerical example under this, so I can rearrange it, and I'll show you what I mean. You might not like what I'm going to do, but you might like it. I would say, for example, 4 equals 6 minus 2. Now, do you see what I mean? The FC, these aren't real numbers. It's just an example. So you agree, don't you, that 4 is 6 take away 2?
Uh-huh.
Yeah, do you see what I mean? That is that minus that. This whole thing here, put it in the bracket. So what is 2 equal? What does that equal? What is 2? 2 is 6 minus 4. Would you agree? Does this make sense to you? It used to make sense to me. In other words, if I want to know this one, this AK, 2 is 6 minus 4. It means AK is F1 minus FC. No? I've done this with students before and they don't like.
It makes sense.
Does it? So, just use a number, use known numbers and make them work for you. Anyway, by hook or by crook, AK, and I'll do it another way if you want me to, but AK then is equal to F1 minus FC. You see what I mean? That 2 is equal to this one minus that, 6 minus 4. So AK is F1 minus FC. But you might get to it a different way, but that's the first thing you have to do. Right? So AK then is equal to F1, which was 4. Do you remember? Minus FC, which is minus 6, wasn't it? FC? Yeah? Minus FC, and FC is negative. So it's 4 plus 6, which is that right? Yeah, it must be, mustn't it? 4 plus 6 is plus 2. Hope that's right. Yeah. AK is equal to F1 minus FC. So its F1 was plus 4, wasn't it? Torah transposition, yeah, plus 4, minus 6, but it's minus, so it's got to be plus. So AK, the value AK comes to 2, right?
Yeah.
Now, it's a bit difficult, this bit, actually. In the exam, the bit we did just now, finding FC, yeah, that bit we did just now, I would say would almost certainly carry 12 marks out of 20. Probably even a bit more. So this is just this, although it's a lot of work, won't carry that many marks. Do you see what I'm getting at?
Yeah.
I would say the majority.
How did you get plus 2? I don't understand. So it's 4 plus 6, no?
Yeah.
So is that not 10?
10, isn't it? It's 10.
It's
Yeah.
10.
I was just making sure that you're all awake. That's what I was
That's why I
doing.
was like, something not right.
Sorry, darling. You're quite right. Plus 10. I thought it seemed a bit low. Anyway, plus 10. Yes. 4 minus 6 is 10. Yes, good. Just making sure that you're all paying attention.
Not sleeping.
Not exactly. So AK is that now. So if A times K is equal to that, K on its own will equal the plus 10 divided by the add, which is 3. Go over that again in a minute. Right? If A times K is equal to 10, K on its own will equal 10 divided by the add. Does that make, because here you're saying A times K is equal to 10. Yeah? So K will equal 10 divided by A. Any good?
Yeah.
You could do this one. Perhaps not. Perhaps I'll confuse things if I use that, but you could do something like that. Anyway, that's what you've got to do. A times K is 10. K will equal 10 divided by the add. Well, if that's the case, then K is equal to 3.33 recurring. Isn't it? 10 divided by 3.
Mm-hmm.
But do keep I know you will keep a check on me, because I've already made one mistake and there's going to be more, right? It's because I've had the coronavirus. You see, it's affected. It's affected me.
You had it?
When?
Yeah,
Did you?
that's why they kept me in this room. Nobody's coming in. I had it in January. Yeah. We're doing fused bifocals. Marvelous. Yeah, I know. January. I came back from South Africa on the 29th of December. And I think the first week in Jan, the only symptom I got was I lost my sense of smell, a taste, but only for about a day. I was eating something. I thought, it doesn't taste like it should do this somehow, you know. It wasn't, there was taste, but not the correct taste. And I thought, wow, no other symptoms, felt perfectly well, no worries at all. So I thought, just nothing. But then when I was tested, I got allergy.
I never got it. I never been tested. Nothing. Healthy.
Because you're young and healthy and pure.
Of course.
See? Exactly.
So have you been vaccinated, Alan?
Yeah, I've had 2 now.
Yeah, I've had 2 as well.
Yeah.
Yeah.
But it doesn't protect you. I had a guy, a doctor from Oxford, came up to see me yesterday or the day before, took some blood and told me a lot of things. And he said, everything's fine. He said, we'll examine your blood because you've had the South African variant. We're really interested in that. But he said, the chances are your Pfizer jab may not have worked terribly well with it, but you'll have antibodies anyway. That's what they're working on as we speak now. They're quite a bit worried that the South African one can bypass the Pfizer jab.
Mm-hmm.
But in any case, the jab, is not 100. Any jab is not, you're not, okay, I'm free now. It's, anyway, enough said. We ought to get back to fused bifocal. So K is 3.33. So we know that K is n minus 1 divided by ns. This is quite difficult, this bit, actually. This last bit that we're doing now, it's quite hard. But that's K. You get marks for finding that. Not D, stupid boy. K is just a ratio, a ratio. K is 3.33. So we know then, this is where we could use the ban the bomb thing. Look, we could say K is n minus 1 over ns minus n. Do you see what I mean? That's putting that here into this. You want me to do it bigger? And we did this. I did this with you before. I know I did. One of these things. Very useful for rearranging equations. N minus 1 divided by ns minus n. We need that one because that's the only one with ns in it, the index of the seg. So ns minus n is equal to n minus 1 divided by k. ns minus n is n minus 1 divided by... Does that make sense, this thing? So if we wanted to know that, it'd be that times that. We know that k is that over that, and that one will be that divided by that. So, as I said, there's quite a lot of work just for this last bit. N minus 1 then, sorry, ns minus n is equal to n minus 1 divided by k. Right? ns minus n is that one divided by k. Well, we can do that, can't we? Because we know this is 0.5 on the top line divided by k, which is, sorry, I shouldn't have put this plus 3.3. I do apologize. I'm getting confused here. It's k is just 3.33, which is 1 over 6. So it's about, is it 0.67? It's 1 over 6.66. Isn't it 0.16? No, I don't know. Can somebody do that?
0.15.
Say again?
0.15.
1.5. Okay, brilliant. So that is ns minus n, and ns then on its own, if ns minus n is equal to that, ns on its own must equal that plus n. So it's 0.15 plus 1.5, which is 1.65. I'll go over that bit again now. So ns minus n, first of all, you've got to just rearrange it. See, the secret of rearrange, if you try to rearrange this now for ns, it's quite hard to do that, get that on its own from that equation. But if you break it down and use the ns minus n bit, then ns minus n, we know k, well, we know that k is equal to that over that. So we could isolate this whole thing, and that's what we've done here. So we know k is n minus 1 over ns minus n. ns minus n is n minus 1 over k. And the whole bit, if you, I say, don't try and isolate, if you've got any formula where you've got, like we had there, if you needed to know A or K, it's unwise to try and get that out on its own. You keep the whole bit. So you've got 1, 2, 3. Having got that, you can then split it down. Do you see what I'm getting at? Trying to isolate K straight away is hard. It's hard enough like this, bad enough. So once again, then K is equal to n minus 1. Sorry, ns minus n is n minus 1 over k, which comes to, is that, which you told me is 0.15, sounds good to me, but that's ns minus n. So ns on its own will be 0.15, take that over the other side, becomes plus, add on n. So the index of the seg goes to 1.65. That's quite hard, that bit. So I'll go over it again if you want me to, but if you could do the first bit, find FC. FC is equal to F1 minus AK, yeah? That first bit we did, which was a toric transposition first and then transposition as well to get it in the correct form. If you could do that bit and get FC, which we did, which was minus 4. Yeah, minus 4, wasn't it? FC in the first one.
Mm-hmm.
You'd get enough marks for that to pass that question. All right? You get, let's say out of 20, you get 12, something like that, maybe even more, maybe 14. But you get quite a lot for that first bit because this next bit depends on you getting the first bit right. Would you agree? You had to get FC right, you had to get F1 right. So I'm not trying to belittle this, but this is a lot of work, this one. You've got to isolate K effective, NS at the end. You've got to isolate K initially and then NS. So I don't want to frighten you with this, but it's quite hard, this. I don't know who set that question. It's certainly, it's on your assignment, isn't it?
Yeah.
I don't know which questions they're using these days because I'm not the examiner anymore. I would never have set that. I've set the first bit, find FC, yeah, and maybe RC. You know, we did find the radius of curvature. Yes, that's up for grabs. But to do this is the sort of question would be in the dispensing optician's final ophthalmic lens paper, DO's final OL, because it's quite hard. It needs a lot of rearranging, and I think it's too hard. I'm not trying to get out of it. I'm just saying, if you could do the first bit, find FC, in other words, it was -4, you'd get enough marks. You've only got to get 50%. All right? But you might want to look over this. Is it okay? I mean, I'll go over it again if you want me